Hey, math friends. So our learning target today, might have started that a little early. Hey, math friends. So our learning target today is I can review Unit 9 on inequalities, so alligator mouth problems, and absolute value. So first learning target is I can represent real-world situations with inequalities. So we're going to talk about real-world problems that have alligator mouths involved. So first question here is Joanna had fewer than 20 minutes to finish her test. So we're talking about fewer than, which means less than 20 minutes. It's not equal to because it says fewer than. If M represents the number of minutes, write and graph an inequality that describes the situation. We would say that the number of minutes is less than 20. I'm not putting the equal to bar there because it doesn't say that it's an equal to amount of minutes. It's just less than. So we have an open circle at 20 minutes, and we're talking about all the minutes that are less than. So we're going to shade to the left. So we're going to write the inequality, and then we're going to graph it. Open circle at 20 minutes and shade left, the number of minutes to finish the test, fewer than 20 minutes. Question 2. The manager said that the wait list at the Olive Garden is the number of minutes is less than or equal to 30. So 30 or less minutes. If M represents the number of minutes, describe and graph the situation. So the inequality is given, so we just need to do a description. So the number of minutes is less than or equal to 30. That would be the description of the inequality. So the graph of that would be 30 minutes with a closed circle. Could be equal to 30 minutes or any minutes less than that. So 29 minutes perhaps, but the manager is not estimating it to exceed 30 minutes. So I'm not going to shade in the direction where 31 minutes is. So less than or equal to 30 minutes. Question 3, you have to be taller than 48 inches, so taller than, not equal to ride on the roller coaster. If age represents height, write and graph an inequality for the situation. So the inequality then would be that your height has to be greater than 48 inches, not equal to, which probably is true in real life, but based on how this is worded, it is not saying that you can be equal to. You have to be taller than 48 inches. So we have an open circle at 48 inches, and we're talking about all the heights that are greater are allowed to ride on the roller coaster. Now, I have to be honest with you. When I was out at Valley Fair at Steel Venom, I noticed that it said that on Steel Venom, you can't exceed a certain height, actually. So that's not true for all of the rides, but this particular roller coaster, you do have to be greater than 48 inches to ride on it. But I was a little surprised. But I suppose because of Steel Venom, you have to, you can't be too tall, or you would be too tall for that ride. That would be scary. Question 4. You have to be at least meaning 18 or more. Ooh. You have to be at least 18 years of age or older to vote. So your age has to be greater than 18, or if you're equal to 18, you may vote in the United States. I don't know if that's true for other countries. 18. Closed circle at 18, because if you're 18, you get to vote. If you're 19, you get to vote. However, if you're 17 in the United States, you don't get to vote. So pretty good connection there. Question 5. Concert tickets are more than $30. More than, not equal to, more than $30. But they're not more than 100. So they're more than the tickets. The price of the tickets are between 30 and 100. They're not more than 100, which means they could be equal to. Now that's that tricky analogy where the variable lives in the middle and the alligators have to go in that direction. That means that 30 is less than the price, which is less than or equal to 100. cannot be equal to 30, so I'm not going to put the equal to bar here on that 30. I'm going to leave that just as a less than symbol. So 30 is smaller than the price, and that is smaller than 100. So that'd be open circle at 30 because it can't be equal to 30, a closed circle at 100, and we're saying that the price lives somewhere between 30 and 100. All right. Question 6. The lowest recorded temperature in Minnesota is negative 60 degrees Fahrenheit. The highest temperature is 114 degrees Fahrenheit. If T represents the temperature, write and graph the inequality. So the temperature lives somewhere between negative 60 degrees and 114 degrees. It says they were both recorded temperatures. So they could both be equal to those temperatures. If they were recorded, that was the equal to on the low end at negative 60 and at the high end at positive 114. So at negative 60 and positive 114, we have a closed circle at negative 60. We have a closed circle at 114. So we're saying that all the temperatures range between negative 60 and 114. All right, so that is your first learning target, and as I can write and graph inequalities. Getting ourselves ready for the review. Learning target number 2 then is that I can solve one and two step inequalities. Sometimes it's in a real world situation, sometimes it's not. Luke solved the inequality below and then graphed it. Describe and correct his mistake. That actually came out of the review when it was in there. So instead of doing that, I'm just going to ask you to solve and graph it. It was handwritten in there, and when I went to print it, it didn't transfer because I had written it by hand. So it was not in the electronic file. So we're going to divide by negative 3, copy, paste, copy, paste. We get x equals. Now, because we multiply or divide by a negative on both sides of an alligator problem, of these type of problems, because I divided by a negative on both sides, I need to flip the sign. Guessing that was the error that Luke made. But I don't have a picture of that anymore in here. So here's the inequality. And the graph of that would be then an open circle at negative 10. And we're talking about less than negative 10, so smaller than negative 10. So that would give us in that direction of negative 11, negative 12, and so on. We are not shading towards negative 9. Question number 8. Solve the inequality, then graph the solutions. So we're going to subtract 2, copy, paste, copy, paste. If I haven't used it, drag it down, drag it down. 38 minus 2 is 36. We're going to divide both sides by negative 3, copy, paste, copy, paste. Now, because we divided by a negative, this sign has to flip. So that gives us x is now greater than or equal to negative 12. Graphing. So at negative 12, we have a closed circle. And we're going to talk about all the values that are greater than negative 12. So let's think about things greater than. Well, negative 11 is greater than because it's getting closer to 0. So with less negative. All right, so that was question 8. Make sure that you have a closed circle there. Shading to the right. Question 9. Solve the inequality, then graph the solution. So this time we're going to solve for P. I'm going to undo that because I should have grabbed that sign out front. It's not going to matter in this case, but we're going to subtract 8. We're going to move it to the other side. So we get 4P is greater than negative 20. Divide by 4, copy, paste, copy, paste. Now, we did not divide by a negative to both sides. We do have a negative in the problem, but we're not dividing. If we look at what we divided by, we're not dividing by a negative. We're dividing by a positive. So we end up with that P is greater than -5. Don't flip sign. So we have a -5 in the middle. -6 is smaller. -4 is bigger because we're talking about negatives. Open circle. And we're talking about all the values that are greater than -5. Question 10, same skill, solve the inequality, then graph the solutions. So I'm going to grab the sign in front here. I'm going to move the 7 out of the yard. So I'm going to subtract 7, copy, paste, copy, paste. If I haven't used it, drag it down, drag it down. So far I haven't multiplied or divided by any negative, so nothing to flip. Next step then would be to isolate. So I'm going to divide both sides by -1, copy, paste. Now, whoops. This is a less than sign. Now I just divided by a -2 both sides. And because of that, I have to flip my sign. So this then becomes y is greater than, and a -9 divided by a -1 is +9. So be aware of that. So we have a 9 with an open circle. 8 is smaller, 10 is bigger. And we're talking about all the values that are shaded to the right. Open circle at 9, shade to the right. Question number 11, graph and solve the inequality. So we are going to hand method here, or build house, build fence. So we're going to isolate for x. So the first step would be to subtract 10, copy, paste, copy, paste. If I haven't used it, drag it down, drag it down. So we end up with -x/3 or -1x/3 is greater than or equal to 0. Ooh, this one is kind of tricky. All right, so as we start to solve here, you can see that we're going to end up with a 0, but I'm going to multiply both sides by 3, just kind of working through the steps of it. 0 times 3 is 3. Isolating the x, we divide both sides by -1. Oh, I'm glad I worked that out, because recognizing here that we're going to have to flip that sign. So because I just divided by a -1 to both sides right here, I'm going to have to flip this sign. So this results then in, which would have been really important because my graph would be different. It results then in x is less than or equal to 0. So we have a 0 here. Okay, and we're talking about a closed circle there. And we're talking about all the values that are less than or equal to 0. So -1 and -2 and so on. So we're shading to the left. All the values that are less than or equal to 0. Closed circle, shade to the left. All right, so same skill here, over and over. Question 12. I'm going to erase this just so I have some space to write. So question 12 here. Solve and graph the inequality. So we're going to go ahead and solve. We're going to add 14, copy, paste, copy, paste. So we get x divided by 7 is less than or equal to -7. We're going to multiply by 7, copy, paste, copy, paste. Nice and high. Notice how I multiply that. Nice and high, nice and high. X less than or equal to -49. Now, do I flip this sign? No. I did have a negative in the problem, but I multiplied both sides by a positive. I get there's a negative in the problem, but I did not multiply by a negative to both sides. So -49, we have a closed circle because it's equal to, so it's less than or equal to, so close the circle. Things that are smaller are -50. So we're going to talk about things that are smaller or less than, shade to the left with a nice closed circle here. Do not shade to the right, which are greater. So closed circle at -49 and shade to the left. Boom. All right, so keep on trucking away here. That is not the right file. Question 13. Solve the inequality, then graph the solutions. We're going to continue to graph these. All right, so this is a multi-step equation that we're going to solve here with the inequalities. So we're going to use the distributive property here. This is going to have to wait because it's on the outside. It's attached through subtraction. So this becomes 2x minus 3 minus 15x If I haven't used it, drag it down, drag it down. Now, combining like terms. So we're going to go ahead and grab like terms. So we have a 2x minus a 15x results in negative 13x minus 3 is greater than or equal to 23. Go ahead, pause video at any time if you need to write, you're not sure, any of those steps. All right, so same way that we always solve. Add 3, copy, paste, copy, paste. The only difference is deciding if we're going to flip the sign. Otherwise, it is the same as any two-step equation you've solved all year. So we add 3 to both sides. Wouldn't have to worry about the sign until we multiply or divide by a negative. So right here, it's happening. Right now, we're dividing by a negative 13. And when that happens, when you divide by a negative on both sides, you have to flip the sign. So this becomes then x is less than or equal to negative 2. So when we go to graph that, we have a closed circle at negative 2. And we're going to shade to all the values that are less than negative 2. So shade left. We are not shading to the right. Next problem. So for this problem, you can see we have the distributive property on the left. And we're going to have a variable on both sides, which means it's a multi-step equation. Same game, though. When we're just solving these, we just solve, try to isolate for y. The only difference with these inequalities is deciding if we should flip the sign. All right, so here we go. We're going to distribute. We're going to multiply through, which gives us negative 21y. Distribute. What does that give me? Negative 175. I better verify. Check the verify team, which AKA means my calculator. That has got to be 175, right? Yes. Minus 175. I was just thinking of quarters. 7 quarters makes $1.75. It's kind of how I was thinking about that. All right, a little bit of a mess on my screen here, but bear with me. If we take a look at both sides, we have this y term on the left and this y term on the right. Smallest y term goes is kind of the general rule of thumb. It's not the law in math, but that's the general rule. So we're going to add 21y to both sides. Do it, do it, do it, do it, do it. If I haven't used it, drag it down, drag it down. This becomes 11y positive, and this becomes, hey, why don't we just drag that down? Now the hand method kicks in, or build house, build fence. Put your hand on that. Move that positive 78 out of the yard. So we're going to subtract 78 to both sides. Copy, paste, copy, paste. If I haven't used it, drag it down is on the right. And I don't have to worry about the sign yet because it's not an issue until we multiply or divide. Then we have to make a decision. So this is negative 253. I just need to double check that that's coming out right. Ah, boom, I got it. I panicked when I saw that 11. Divide both sides by 11. Now, did I divide by a negative to both sides? Here's a divide by 11, divide by 11. Did I divide by a negative? No. I recognize, as I've stated a million times, that there is a negative in the problem, but I did not divide by a negative, so I'm not going to flip the sign. So it's 23 is less than y. Now that makes me uncomfortable when I graph, so I'm somebody that likes to flip the entire quantity around and get the variable on the left. So that would be y is less than 23. That's kind of something in my comfort zone, more of that. So here's 23. We have an open circle at 23. And we're talking about all the values that are less than 23. So we are going to shade to the left. Boom. To the left. All right, here we go. Still working on that same skill, but this is a double inequality that's happening here. Okay. So what happens if we have a double inequality? It's really the same thing, except we have a paste going on, which we've talked about before in this course. So we're still trying to isolate. So we have this n that's stuck in there, which means this positive 2 has to move out, but it has to move over both fences this time because the double inequality. We have 2 fences. So we're going to subtract 2, copy, paste, copy, paste. So we end up with negative 9 is less than negative 3n, because that became 0, is less than 21. I think it's time to erase all this. Otherwise, it is such a disaster on this page. You just need to rewind if there's anything you need to go back. So here's my variable n. We're trying to isolate. So we're going to divide like we always do, divide by negative 3. But the difference is we need to paste and paste. Now check it out. Look what happened. We divided actually everything by a negative. And because of that, these signs have to flip. So we end up with positive 3 is greater than n is greater than negative 7. We have to flip the signs now because we divided both sides by a negative 3. So now we are going to switch this from least to greatest, which becomes negative 7 less than n less than 3. Make sure it's listed from least to greatest. So we end up with a negative 7 open circle. We end up with a 3 open circle, and we're talking about that n lives somewhere in between negative 7 and positive 3. So that would be your inequality that you solved and the graph for it. All right, new learning target. I can solve absolute value equations. All right, absolute value equations. So as we start to solve, you know that you will have 2 answers for each of these, if they're possible. Sometimes they're not possible. So we drag to the left and solve exactly how we have it. We drag to the right and solve exactly how we have it. So we're going to add 4, copy, paste, copy, paste. We get x equals 14 as our first possible solution. X equals 14. So we solve it exactly how we see it. We just drop the bar. Because it's absolute value, you get 2 possible answers. So then I also write it again, but this time I make it negative. So x minus 4 equals negative 10. I add 4, copy, paste, and I'm left with then x equals negative 6. So my 2 possible solutions are x equals 14 and x equals negative 6. Check it out. X equals positive 14 and x equals negative 6 are the 2 possible solutions for that situation. All right, solve and check. Here we go. Absolute value. Now to do that, we need to isolate the absolute value before we can do any splitting. So we got to isolate that first. So clean up the yard before we split. So I subtract 15 to both sides. So I end up with x plus 7 is equal to, that comes out to negative 4. So this is the step where I would do the splitting on this problem. But you should recognize that it is impossible in an absolute value problem to get a negative output. So this is actually no solution. There's no possible solution for x that when you take the absolute value of it, regardless of what x is, that you will end up with a negative coming out of there. The only time that's possible if there was a negative sitting on the outside, which meant take the opposite of your answer. So there is no way that this is possible, no solution. So that's a time where we wouldn't have two answers. I said earlier, anytime you take an absolute value, you have 2 answers, but not in that scenario. Question 18. Again, we need to solve the absolute value, get it alone. Okay, coolio. This has to be alone before we can split anything. So we're going to subtract 10, copy, paste. So we end up with the absolute value of 4x plus 2 is equal to 8. So now we're going to drag to the left, which is 4x plus 2 equals 8. And we're going to drag to the right, which is 4x plus 2 equals negative 8. We're going to solve both. So we are going to subtract 2, copy, paste. So we get 4x equals 6. Next step, of course, is to divide by 4, copy, paste. We get x equals 3 over 2. Now, of course, you can write that in other forms. You could write that as 1 1/2 or 1.5, but there's my first possible solution for this inequality. We will end up with 2 solutions as long as it is no solution. As long as we're not in a situation where there's no solution is what I meant. So there's my first solution. Same game over here, of course, except I just made the output negative. So I just made this negative, which is my other solution. So I subtract 2, copy, paste, drag it down, drag it down. We divide both sides by 4, copy, paste, copy, paste. So we get x equals, and this would reduce to negative. Divide the top by 2 and the bottom by 2 is negative 5 over 2, which also equals negative 2.5. So this would be my second solution. X equals, that would be my second solution. So 1 1/2 and negative 2 1/2 are the 2 solutions. Again, I'll highlight those. This is one solution. That's the other solution. And you can use them in other forms like, fraction form also works. So my 2 solutions are either in green or in blue. All right, here we go. Let's keep going. So we're still solving these. It's going to be a pretty long video, I think, today because we're reviewing everything in the unit on absolute value inequalities. Okay, so we start to solve. First step is to isolate the inequality or the absolute value. So we're going to subtract 20, copy, paste, just like we would in the hand method. I'm going to erase that, otherwise I'm not going to be able to see those absolute value bars. Drag it down, drag it down. So we get negative 3 times the quantity of 4x plus 2 equals negative 12. Watch that sign over there. Next step is that this is multiplication, so we're going to divide both sides by negative 3, copy, paste, copy, paste. So we get 4x plus 2 is equal to, ooh, good, positive 4. I was a little worried that we're going to get a negative coming out of that, and then we have a real problem. So this is an absolute value problem, equals positive 4. Because it's a positive output, we can split that with 2 possible solutions, which is 4x plus 2 equals 4. Okay, and then we can split it again to the right, which is 4x plus 2 equals negative 4. And then we're going to solve. So we're going to add 2, copy, paste, copy, paste. So we get 4x equals 2. Divide both sides by 4. We end up with x equals 1/2, or x equals 0.5 is our first possible solution to this system. One of these, 1/2 or 0.5. Likewise, solving the other one, we're going to subtract 2, copy, paste, copy, paste. So we get 4x equals negative 6. Divide both sides by 4. We end up with x equals, you get negative, divide each of these by 2, you get negative 3 over 2. So the result of that is x equals negative 3 over 2, which also is the same as negative 1.5. So x equals negative 1.5. So your 2 possible solutions for this problem is x equals 1/2 or 0.5, or x equals negative 3 over 2, which is negative 1.5. Oh boy. So we're already at 28 minutes, but that was question number 19, I believe. All right, so we got to keep going here. All right, so question number 20 is coming up. So question number 20 is, what about when we have absolute values that have an inequality with them? So we know that, first of all, they can't ever be negative, right, coming out of there. And we know that they always have 2 answers. But the inequality works a little different. So not only do we split it like we've been doing, but we also have to flip the sign on the second one. So I'll show you how this works. First one, we go to the left. Now, you know there's an entire video on this. This is just the review for the whole unit. So there's a whole lesson just on this. So we drag to the left, keep it. And then here's the key here is we drag it to the right, flip it, and make it negative. Flip it and make it negative. So then to graph that, we are going to graph at, here's 0, here's 1, a closed circle at 1, then we're shading to the left, a closed circle at -1, and we're shading to the right. So this graph is going to go in between -1 and -2. So it would be -1 is less than or equal to x is less than or equal to 1. Go ahead, pause that video, watch that again over and over. So we're talking about all the values that are less than 1 would be like 0, -1, -2. We're talking about all the values that are greater than -1 would be like 0, 1, and so on. So they overlap there. So that's kind of the first one. Next problem, again, we have to isolate the x, which we did. We drag left, which is x greater than 5. When we drag right, we not only make it negative, we also have to flip the sign. So my quantities are at -5 and 5. They both have open circles, but you have to be very careful on how you read this. That at 5, it says greater than. So go to 6, 7, 8, and so on. At -5, it says less than. So go to -6 and so on. So this time the graph is growing away from each other with an open space in between. Next problem. Now remember that these always have to have an isolated absolute value before you can start. So we're going to drag to the left, which is x minus 5 is greater than 7. And then we're going to drag to the right, which is x minus 5 is less than or equal to -7. All right, so as we start to solve then, we add 5, copy, paste, paste. We end up with x is greater than or equal to 12. And notice I flipped the sign here and made it negative. So we add 5, copy, paste, paste. We end up with x is less than or equal to -2. So we have to graph those then at -2 and +12. Both of them have equal to bars, so we're going to shade circle here, shade circle here. So if we talk about greater than or equal to 12, we're going to shade to the right. Less than or equal to -2, we're going to shade to the left. So again, we're growing away from each other again on this particular problem. Okay, question 23. We're going to isolate here. So our job is to get the absolute value bar alone. So the first thing that we're going to do is we are going to subtract 7 from both sides. So we get -2 times the absolute value of x minus 5 is less than -8. The next step then would be to divide by -2 to both sides. So we get x minus 5. Because I just divided both sides by a negative, we have to do what? We have to flip the sign. We have to flip the sign. I didn't mean to highlight that 5. So flip sign, and now this is +4. And just make absolutely sure we don't have a negative output coming out there. So we end up with x minus 5 is greater than 4 on the left. We rewrite it on the right, which is x minus 5. We flip the sign and we make it negative. Flip sign and make negative. We add 5 to both sides. So we get x is greater than 9. We add 5 to both sides. We get x is less than 1. And I know that's super fast. Just click pause. Open circle here, open circle here. X is greater than 9. We shade to the right. X is less than 1, we shade to the left. And sometimes it's a good idea to let it roll out a little bit and watch it for a little bit in a chunk and then rewind it. so that you can kind of see it work out as one big chunk, and then you rewrite. Question 24, same plan. We're going to isolate right here. We're going to isolate. So we're going to subtract 7, copy, paste, copy, paste. So we get 4 times 5 minus 2x is less than 20. Divide by 4, copy, paste, copy, paste. So we get 5 minus 2x is less than 5. So at this step, then we would want to split the problem into 2, just making sure that the output isn't negative, or we're going to have some issues. So I'm actually going to take, if I can, I'm going to move this, okay, for the sake of just having more room. So I took this and I rewrote it over here. So we're going to drag to the left and make negative. And we're going to drag to the right and make positive. Or we're going to, this is getting to be a long video, but it's the whole unit. 5 minus 2x, we flip the sign and make negative, is what I meant to say. All right, guys, so hang in there. So what we're going to do here is we're going to isolate for x. We're going to subtract 5, copy, paste, copy, paste. So we end up with negative 2x is less than 0. Now stay with that one. So we divide by negative 2. Because I just divided by a negative on both sides, this sign has to flip. So it's x is greater than 0. So open circle at x is 0. Likewise, over here, we need to solve. So we're going to subtract this 5 off. If I can get my pen to work. I'm going to pause video for a second. All right, guys, my pen is working now, so we should be okay. So we are going to solve this then by isolating the x. We subtract 5, copy, paste, copy, paste. If I haven't used it, drag it down, drag it down. And this becomes negative 10. So now the next step would be to divide by negative 2, copy, paste. You know that when you divide by a negative, you have to flip the sign. So this becomes x is less than 5 because I divided by a negative. So if we go back to our graph here, we have an open circle at 0. We have an open circle at 5. We're talking about all the values that are greater than 0 and all the values that are less than 5. So we're shading in between there. Open at 0, open at 5, shading in between those. So that means x lives somewhere in between here. So that was question 24. I just had to move it kind of into that space. All right, question 25. I'm going to pause the video for a second. Okay, question 25. At a carnival, the cost to get in is $4 plus $1.50 for each ride you go on. So this sounds like a y-intercept. This sounds like a slope. Write and solve an inequality that describes how many times you can go on the rides if you have a $20 bill. So $1.50 for each ride, I'll use R for the number of rides, plus $4 to get in, and you have less than or equal to $20. So that would be the inequality setup. You can't spend $21, so it has to be less than or equal to, but you can spend the entire $20 bill that you have. So we're going to basically solve that. So that's step 1 is to write it, and then step 2 is to solve it. So we're going to subtract 4, copy, paste, copy, paste. So $1.50 R is less than or equal to 16. So after you get in, you have $16 left to go on rides. They're $1.50 a piece. So I'm going to divide by $1.50. You do not have to flip the sign because I did not divide by a negative. In 16 divided by $1.15. Let's see what that comes out to be. $1.50 I meant. comes out to 10.7 rides. Now, it's not possible, maybe somehow they can figure that out, but it's not possible to go on 10 and, 2/3 of a ride. So, therefore, you really only have enough money to go on 10 rides. So, you'd have some change in your pocket left over. 10 or less rides. That's what that symbol would mean. 10 or less rides. You cannot go on 11. You don't have enough money. All right. Almost there, guys. So last page is dealing with all sorts of word problem scenarios, all real life situations. Now, you know this is the review for the entire unit. So that's why it's super duper long in preparation for it. If you struggle on any of these individual learning targets, I do have a video for each one of those. So you could just watch that topic in isolation if you're just struggling on one thing. John earns $12.50 per hour mowing. Okay, so that would be a slope. He's saving to buy a tablet that costs $2.99. Write and solve an inequality that describes how many hours he needs to work to buy the tablet. So $12.50 per hour. And he needs to make at least a $2.99 or equal to. Equal to, he can buy it. But is it okay if he makes more than $2.99? Sure, he can save the money. So that would be different than having only $20 in your pocket to spend on rides, like we just talked about. Is that it's okay if he has extra money in that he's saved, but he needs at least $2.99. So we're going to divide both sides by $12.50. I am not dividing by a negative here, so I don't have to worry about flipping that sign. I forgot the variable. Hours, H. So H is greater than or equal to, so we're going to take $2.99. We're going to divide it by $12.50. Gives me $23.92. So the number of hours he needs to work is greater than or equal to 23.92 hours. Now the question is it possible to work part of an hour? Yeah, you can. It is possible. You could work 23 hours and 56 minutes. That is a real thing that is feasible. So that one would be acceptable. We do not have to graph that, so we can move on. Question 27. Tom earns $100 to start a painting job. Ooh, that sounds like a B to me. That earns $25 per hour to complete it. That sounds like a slope. He needs to save more than 900, not equal to, more than 100 for his trip to Florida this summer. Write and solve an inequality that describes how many hours he needs to work to save enough money. So $25 per hour, $100 to start. He needs to save more than 900. So right away at the start, we can subtract off this 100. So that means that he only has $800 left that he needs to earn. So we're going to divide both sides by 25. Notice we're not dividing by a negative, so we don't have to worry about flipping the sign. So we get H is greater than 800 divided by 25 is 32 hours. He needs to work more than 32 hours. So explain your answer in words. John would need to work, or Tom rather, would need to work more than 32 hours. I just am out of room, so I'm not going to be able to write it out in words. Same thing here. All right, almost done. Last two problems. Last two problems are on kind of standard deviation stuff. An essay contest requires that an essay entry consists of 500 words with an absolute deviation of at most 30 words. So we talked about this, that this is an absolute variable situation. It says, write an inequality to represent the situation. So perfection would be 500. We want to be within the standard deviation of 30 words at most. So we will allow plus or minus 30 words. So less than or equal to 30 words is the standard deviation there. So this is the setup. As if you go back and watch the video on absolute deviation, you would remember that this is the perfection, like the perfect score. This is what we will allow for error. So that's the setup. That would be the actual answer to that. But to solve that, then we would drag left keep it exactly the same. We would drag right, we would flip the sign, and we would make it negative. So what are the possible acceptable values with a standard deviation of 30 words? We will allow up to 530 words. We will allow a minimum of 470 words. So our standard deviation then would be that the number of words could range from 470 to 530, recognizing that our perfection would be 500. But this proves that we have a standard deviation of 30 each way. Please pause video at any time, but we're already at 45 minutes, so I'm going to keep rolling at my pace. Last problem of the day. A candy manufacturer puts 240 pieces of candy into each bag. Trick or treat, right? All right, that's perfect. That's perfection according to the manufacturer. So we put perfection in our deviation equation here of that's our perfect score, 240. The bag should not be off by more than 8. So not more than 8. So we'll allow it to be equal to 8 off either direction. Now, to prove how absolute value works, so that was the setup, which is kind of all the question is asking, is to write the inequality. But I'm going to go ahead and solve it to finish up the day here. That's step 1. Step 2 would be to write it again, flip the sign, and make it negative. So flip sign and make negative. So as we start to solve, we're going to add 240 to both sides. So we got x is less than or equal to 248. So as long as they don't put more than 248 pieces of candy, we're going to consider that okay. Of course, there's always tiny mistakes that are made in manufacturing as the candy is running through the assembly. So we're going to add 240 to both sides here. Sorry if that's hard to read, which means it's up down to 232. Now that probably is not going to make people very happy if they only get 232 when they thought they were going to get 240 according to the bag. But they're going to take a few complaints on if it's down to 232. But anything less than that, they would stress out a little bit that they're making customers really unhappy. They didn't get what they asked for. So the number of pieces that they'll allow for is anywhere from 232 to 248. Of course, the idea is that perfection is lays at 240. That's perfect. But you can see we're 8 pieces of candy either way. So that is the entire unit review on inequalities and absolute value. This is a long one, but it is a super important one for future algebra courses. So make sure you're practicing. You got to go through these lots of times. Push pause, rewind, try it again. Have a glorious night.